Got to give the people what they want. What is this? I think this is like 4.5, and we are graphing sine and cosine with no period shift. So pause it right here. Write all this stuff down that I have on here. Just draw the pictures, write it down. Notice how I have things lining up with the lines so that you can count. Okay, so just go ahead and do that. All right, perfect. So let's talk about what we have. So you already drew this, so now you're just looking at it and you're listening. All right, so this circle right here is our unit circle, okay? This right here is our x and y axis. So the unit circle lives on the x and y axis, right? So we have the point 0 or 2 pi, sorry, not the point, the angle 0, 2 pi. We have the angle pi over 2, which is a 90-degree angle. We have a pi angle. We have a 3 pi over 2 angle. And then we're back to our 2 pi angle. All right, all that is familiar. And we are also noticing that, you know, from here to here, this radius is 1. From here to here, this radius is 1. Radius is 1. Radius is 1. All this is stuff that we know because this is a unit circle. Now, imagine, though, that this unit circle represents a Ferris wheel that magically travels underground, right? So the x-axis is the ground, right? So this is like the Ferris wheel. So this circle is like a Ferris wheel that is above ground, right? So if it was up here, it'd be above ground. And if it was down here, it'd be magically underground. Obviously, this is not possible, but that's what we're imagining right now, okay? So now, I'm going to refer to the x-axis as the ground, and I'm going to refer to the y-axis as the pole. This is the pole that is holding on to the Ferris wheel. The Ferris wheel attaches at that pole right there. So the Ferris wheel is rotating around this. Again, you're not drawing all of this, but you are just visualizing a Ferris wheel that goes above ground and underground, okay? All right, so now, what we're going to do is we're going to take this Ferris wheel and we are going to basically move around the Ferris wheel. So I get on the Ferris wheel right here. So when I get on the Ferris wheel at this angle, how far am I from the ground? All right, you're like, oh, I'm on the ground, right? So at the angle of 0, I am on the ground. So I'm going to put a point right there. Okay? Now, I'm going to imagine I'm just sitting in the chair on the Ferris wheel. It is rotating counterclockwise, and I get to here. I get to this angle of pi over 2. When I'm at this angle of pi over 2, well, where am I? I'm way at the top. I'm high off the ground. I am 1 meter or 1 unit, whatever, right? Because it's the radius. I'm 1 off the ground. So at pi over 2, I am at 1. I'm at my highest point. So I'm going to put a dot there. Okay? Now, I'm rotating around this Ferris wheel, and I'm actually going down, 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 till I get to this angle at pi. Where am I now? So you should be like, oh, I'm starting to get this. Ah, snap. I'm back on the ground. Boom. I'm back at 0. So I'm going to put a point there. So now I'm going to keep rotating on this Ferris wheel, this magical Ferris wheel, and I get to my next angle right here, which is at 3 pi over 2. Well, where am I? You should be like, oh, crap, son. You are underground. I am underground. I am at -1. I'm underground, so I'm right here. Finally, I keep rotating around. I'm going back up, and at 2 pi, I end up back on the ground. Okay? So if I do a curve, which you all will see, I get a graph that looks something like this. Right? The measurement of height, right? If I just keep measuring height all the way around here, right? I took all those measurements of height. Is that sine or cosine? That's a measurement of y, which should tell you that that is sine. So, sine is like the distance from the ground. And again, this is kind of a quick, dirty version of this. We're going to work on it, but I wanted to give you some of the background. All right? So now, draw a new picture. The exact same picture, just draw a fresh version of it. But now, we're going to do the same thing, except we're going to change what we are judging. So this time, right, because you already paused and you drew it, instead of measuring the distance from the ground, we're going to measure the distance from the pole. So, when I get onto my Ferris wheel, which is right here at this spot, how far am I from the pole? Well, I'm here, right? That means I'm 1, right? So when I get on at 0, I'm as far as I can be from the pole, from there to there, right? And as I start to rotate around this Ferris wheel, when I get to here at 1/2, well, how far am I from the pole? Remember, the pole is the yellow, the y-axis. Well, I'm on it. So I'm actually no space from the pole. So I keep rotating around and I get to this angle of pi. When I'm at pi, oh man, I'm behind the pole as far as I can be. -1. So at pi, I'm at -1 behind the pole. I rotate around again and I get to 3/2 pi. And where am I at? Well, I'm right here. I'm touching the pole again. I am no distance from the pole, so I'm at 0. So 3/2 pi, I'm at 0. Distance from the pole. Remember, this is a distance from either the ground or the pole. This is the distance from the pole, just to make sure that we're clear on that. Right? And finally, I keep rotating back up here. I get back to where I started, and I am as far away as possible from the pole, so I am at 1. Okay? So this makes a curve that looks something like this. Guess I should have curved this a little more. Ugh, let me do that a little better. Okay? So this is distance from the pole, and that is cosine, because cosine is a measurement of the x-axis, right? So we're seeing how far we are along the x-axis, which we saw. We know the sine, like think of the part of the triangle each of those pieces would be. It would be the x-axis, that is cosine. So distance from the pole is cosine. Distance from the ground is sine, okay? They have two different graphs. That's all I'm going to have you do tonight. We're going to talk a lot about this in class, but I wanted to at least get this part in your head once so I don't sound crazy when we talk about it tomorrow. Mr. Bass, I'm out. Don't worry if you ain't got everything, but you'll be good. You got this. Peace.